Hey, thanks so much for joining tonight. My name is Matt Jacobs, and today I'm going to be sharing with you about my research project, Novels Methods of Composites Recycling via Pyrolysis. Thank you, SAMPE organizers, for putting on the University Research Symposium still, so I'll jump right in. I want everyone to start by thinking about their next car purchase. Is this car, compared to what you have now, faster? Does it get better mileage? Is it safer? Is it cooler looking? The composite industry provides the answer to all of these questions, of course, yes. Composites are a wonderful material, and I'm going to be speaking a bit about how we can make sure they're even more wonderful in the future. So we know they're so small, right? Carbon fiber filaments have a tiny diameter, especially as seen here, compared to a human hair. But when composite fibers are combined with the resin system, together they make a really powerful combination. And this rocket fin here, this body tube, it's a pretty amazing thing all on its own. There is a problem though, and that's if you have a bunch of leftover rockets once you're done shooting them all, what are you going to do to reuse them? Basically, the problem statement is how can you separate the resin from the fibers and then be able to reuse the materials? So my research focused on a number of ways to do that, but identified one in particular that we should think more about and move forward with. One way that carbon fiber recycling is done is through solvolysis, as seen here. These pictures are from a company in Colorado called Melinda. The fiber is in a solvent bath, and the solvent slowly dissolves the bonds, the thermoset bonds that make up the epoxy resin system in the composite. As a result, you get great quality fibers that come out of this bath. They're in near virgin state, in fact. So this is a good thing in addition to the process being relatively inexpensive and relatively quick. There are only certain resin systems that work with solvolysis, and as well as you can see here, the process is somewhat messy. There are also other alternatives though. Another way that you can recycle carbon fiber is through pyrolysis, which is what my research focused on. So in this instance, you have carbon fiber that is burned at a very hot temperature, and the bonds are broken as they are burned away. What you have left over are just great quality fibers and not much else. The fibers are burned just through a conveyor typically in the industry setup, in one end, out the other, and the product is very, very clean and pure when it's done. There are some downsides though. The fibers are limited to chop strands, and the process is pretty energy intensive. It requires a lot of capital to keep it going. So as I thought about these two methods and what I could do to improve them, I identified a few ways that I could do that. So as my senior year at BYU rolled around and I was thinking about these problems I've been learning about in my composites classes, the honors program on campus allowed me to get my feet wet as a researcher in earnest, and as well opened up some funding for me to be able to pursue a few opportunities that would help me learn more about this. As fate would have it, I ran into this guy, Dale Brogius, at a SAMPE dinner in Salt Lake City. Some of you may know Dale from his work at IACNI. And so we connected on LinkedIn, and then a little while later, he shared an opportunity to go learn more about composites in Germany, which I was happy to take him up on that opportunity, and I'll speak a little bit more about that here in a minute. My research was also supported by Andy George, who you may also know as Utah's SAMPE chair. Dr. George is a great advisor just in general and a good friend. And I saw in my undergrad, my first few years, that he was really good about supporting these other students, and so I knew that eventually I wanted to work with him. So I became a TA for his classes and worked in his lab. And eventually I came across an old prospectus from a master's student who had accepted a full-time offer and needed to quickly change topics and go work in his new job. So for me, this research that was abandoned by this other student promoted a great opportunity for me to just jump right in and start some real high quality research as an undergrad. So after my lit review, like I mentioned earlier, I was able to go travel to Germany as part of my research. So I attended as a part of a trade delegation group from people of different businesses in the US. There's me back there. And we visited a number of companies in Germany, many different cities. And one particular thing that I saw on the agenda and I knew I was going to be so excited about was visiting the Fraunhofer Institute. where they had to set up a machine for that exact process that I wanted to study. In fact, this is where they invented composites pyrolysis. So in this process, the noble gas argon is used to help stabilize the burning process. The fibers are cut into short lengths, and then they are wet pressed over this plate that has a bunch of indentations in it. And then as well, the result of this is a nice chopped matte carbon fiber product, which is sometimes used for insulation under hoods in cars and things like that. So this is an amazing process. Of course, there's been a lot of time and resources invested in this. And I thought, you know, I think I could make something a little bit smaller scale, but inspired by this at BYU. So I set out to do exactly that. I got hold of a really hot oven from some friends in chemical engineering, and as well developed a chamber setup to help make sure that everything was nice and clean inside. So I got this kiln, and I machined a combustion chamber made out of aluminum, and I had a port coming in for nitrogen, so I could get that nice stable inner atmosphere inside, and a vent out for all the off-gassing. And this allowed me to compare, okay, so if I have pyrolysis in an inert condition, it's the favored, typical classic research process for pyrolysis. What if I compared that to no inert gas, just ambient atmosphere in the combustion chamber? So this is what my research changed around, is does the ambient atmosphere provide as good of a pyrolysis process as the inert conditions? And so you'll have to hang on for a minute to learn about that. But that was the main question that I want to think about. So there's my nice chamber and my vents and all that. I'm going to walk you through now what I did to discover this step by step, inert versus ambient. So first thing that I did was I cured a bunch of these small little carbon fiber samples. They're about 2 inches square and a 2-ply stick of just some pre-preg that we had left over in our lab. After I weighed them, I would burn them into my composite chamber that I just talked about, and the resin would slowly off-gas. You can see some of that coming out of the vent tube. Then I would weigh the fibers again and see how much came off. And typically it was a pretty sizable amount, about 40% weight reduction was the most that I saw. So a lot of the resin was burning off. And then I was able to compare that to the known resin content to determine what percentage of the resin I was burning. And I was really happy to see that for both processes, most of this resin was going away. So then in turn, the fibers were cut to size, about 3 millimeters in length, and then blended with high density polyethylene in an oven at 350 for about 3 hours, and I would mix them. And then the fun part, go ahead and loading them up on our tensile testing machine and getting some data from it to see, okay, which of the recycled carbon fibers blended with that HDPE was the best. Another cool part about my research was that I was able to use the SEM on campus to really get some good pictures and findings from my work. So I'm going to move myself over here. So this is pretty sweet. BYU has a great SEM lab, and I sought some training and got it for my project. And I had some of that funding earlier, like I mentioned, to cover my time. So I got about 35 clean pictures, and I'll show you a couple of them here in just a sec. Here you can see carbon fiber that was fully cured. And you can almost see that these little filaments, it looks like they're floating in a bath or a pool of this resin. That's how it looks when there's good resin, good disbursement there. However, if you were to just try to bond new composite together off of this panel, you would not get great bonding because they're already all filled in. With the pyrolysis process, you can see that that really opens up, and that these fibers are, even though there's a little bit of this residual resin left over, they are really ready to accept some new resin system that can bond in there. So that's a very clear before and after picture of what pyrolysis does at a really small scale, so you can see it. Let me show you here my tensile testing results. After I got these images, I was really excited to see what the data would show. So here it is. With the Instron, I made a bunch of different samples, just some basic carbon fiber, 100% carbon, just to see. Here's my HDPE, and then as well, my recycled carbon fiber mixed with the HDPE. Both of these were 10% by weight content, fiber content. Some were, again, in nitrogen, and some were ambient. So I made sure to keep track of both of those and keep them nice and separate. So I pulled the material, got the data from that. Here's a chart that just shows the total amount of my experiments, these groups that I just was outlining. And here's my chart. So with these samples, you were able to see a really classic stress strain curve, really good characteristics, just like it should look. Adding 10% recycled carbon fiber to the HDPE meant some pretty big changes. Here you can see the ultimate strength with a figure of 4.57 KSI for the recycled carbon fiber in ambient conditions as compared to 3.16 KSI with the HDPE. Pretty big change. As well, the modulus was even more significant. So with that ambient carbon fiber, we saw a marked increase from the HDPE baseline. This was really significant to me because that showed that the ambient, of course, both recycled carbon fibers, of course, you add that to the HDPE, you get better mechanical results, makes sense. But I was interested to see that that ambient recycled carbon fiber did have an edge over the nitrogen sample, the inert one, which is great for mechanical properties, but also from people who want to incorporate this process. It's of course easier and less expensive if you don't have to invest in that nitrogen setup to burn everything off and for pyrolysis. So that's pretty nice. Let me talk a little bit more about the significance of some of these. Immediately I knew this is great, but there's going to be more to this. So I was surprised that the ambient recycled carbon fiber did as good as it did, if not better even than that nitrogen sample. And of course, this means that if you are a business owner and you want to incorporate recycled carbon fiber as part of your portfolio, it really could be as simple as just getting some old fibers, burning them, chopping them up, and putting them into your product. It's really, really pretty cool that at a basic level, you could do that. When I presented my thesis to my defense committee back on campus at BYU, they had some interesting insights too, ways I could maybe change this for the future. So here's a picture of my committee. There's Dr. George on the right and Dr. Hivansky at BYU on the left. And of course, I was very happy to have passed, so we're all celebrating there. They suggested that I actually improve the design of my furnace, my aluminum combustion chamber a little bit, to allow for argon to be plumbed into the chamber. And this is so that any remaining oxygen can be purged from the chamber. Of course, nitrogen has a little bit lighter molecular weight, so there's probably just lighter molecular weight than oxygen. So there's going to be a little bit left over on the bottom, and argon would sink to the bottom. It's heavier molecular weight than oxygen, so it would just purge that out. And I did think about that, but honestly, the argon tank was like twice as expensive as the nitrogen one. So that's the main reason why I didn't do it, but I need to maybe ask for some more funding for my next round so that I can have that. As well, there's other data that's available that talks about how unsized carbon fibers, as in like not recycled ones, when combined with HDPE, could compare to my current results. So that was an area that I did not test. And as I searched afterwards, I thought, this is good feedback from my defense committee. I should try to see what's out there. For my specific criteria, I was not able to find data for that. But all that means is that when I do some more studies here, once COVID comes down a bit and I go back to grad school, I have the chance to make some of that, maybe at Purdue or Notre Dame campus. And as well, the CEO of Melinda, that Composites Recycling company I mentioned earlier, was also on that Germany trip and offered to host me for some research there too. So maybe pyrolysis is also a great avenue for me to pursue. Really exciting conclusions as a result of these things. So in the industry outlook, this is also within the scope of my lit review and some of my research. A lot of these automotive companies out there are not super interested in pursuing these composites generally due to cost. So if they adopt a recycled carbon fiber, that will lower that cost of entry and help them want to pursue this. Of course, and in some countries, composites recycling is already required, such as countries in the European Union. So this is actually pretty much a no-brainer. In fact, companies like BMW and Audi are already incorporating a large recycled carbon fiber content into their current part portfolio. In the aerospace industry, you don't have as many barriers to cost, so companies aren't as incentivized to produce materials that are as friendly with recycled carbon fiber. However, with more and more airframes being majority composites, we really need to think about how these airframes are going to be recycled or disposed of at the end of their useful life. So there's a lot of collaboration, more so in aerospace and in automotive, to help solve this problem. And I want to draw our minds back to the very beginning where we thought about our next car. Who knows, maybe your McLaren down the road will be made from recycled composites as well. So thank you again for attending, and I'm looking forward to learning from the other submissions as well, and I appreciate you. Thank you.